Uh, Today, I would like to make a little summary of our architectural design presentation. As you remember, we have three main codes and standards: Turkish Fire Code, NFPA 101, and NFPA 5000 that we follow during the architectural design. We had the definitions: building height, construction, and high-rise building. These are one of them. Building height is measured from the ground level to the roof, and the construction height includes basement floors into the measurement. I would like to just summarize to remember what we are looking for during architectural design of the buildings. I will not focus on these issues. This is a sketch of the measurement of the building height. And when the building is high-rise, as per Turkish Fire Code, high-rise building means your building height is exceeding 21.5 meter, or the construction height is exceeding 30.5 meter. When the building is becoming high-rise building, the automatic sprinkler system and landing valve system and any other and another system that we will talk about are becoming mandatory and should be provided within the building. And both the main technical rooms and the existence of this system within the floor, especially on the ceiling, will affect your architectural coordination and design. And it is better for architects to understand what we will have while we are designing the building. Otherwise, you will become aware when the MAP designer submitted their drawings, but it will be too late to coordinate them. It will cause you a problem to find place and locate these additional systems. When we look at the automatic sprinkler system that you see on the left hand side of the slide, this is automatic suppression system. You can see in many of the high-rise building and shopping malls and any other assembly buildings such as theaters. It is becoming mandatory for residential buildings if the construction height exceeds 51.5 meter. And for non-residential buildings, the limitation is 30.5 meter. But for the hotel and dormitories, it means where the peoples are sleeping, the limitations is much more less than the other buildings. It is only 21.5 meters. It means if you are designing hotel, dormitory, or any kind of sleeping building, you should make an attention to the requirements of the automatic sprinkler system. And we have landing valve system for the high-rise buildings. It is located within the staircase. It means while you are designing the staircase, you should find a place to locate the landing valves. Otherwise, it will cause you a problem during the coordination of the systems. And also for the high-rise building, we have a requirement for pressurization system. If the construction height exceeds 1.5 meter, or the height of stairwell from the lower level to the ceiling of the stairwell exceeds 30.5 meter, or the stair serving more than 4 basement floor, should have a pressurization system. Likewise, if you have a fire service access elevator, it means the construction height exceeds 51.5 meter. This fire service access elevator well should also be pressurized. We will talk about the effects and the consequences of having pressurization system. We need to find a place to locate the fans, and also we need to find a place to locate the shafts, which should be neighboring the stairwell and the elevator well. Also, we will have some corridor exhaust systems for high-rise buildings with construction height of more than 51.5 meter, and the hotel and dormitory, without looking at the construction or building height, if the corridor length exceeds 45 meter, Either you need to divide the corridors into parts not more than 45 meter, or you should provide a corridor smoke exhaust system. When you have a corridor smoke exhaust system, you need to provide additional shafts for mechanical designer, and it will affect the core design of your buildings. That's why this is also important. And in Turkey, while you are designing your building, the facade design is also very related with fire and life safety. The main thing is the material selection during the facade design, and we already talked about within the architectural design lesson. Today we will see the details of the facade, which means as per Turkish fire codes, you either have 1 meter to 1 meter of parapet having a 2-hour fire rating between the floors, or you need to provide a closely located sprinkler facade protection to prevent fire coming out from the window and to reach to the upper levels. The main purpose is that. And that's why if you don't want to have facade protection very closely located, 1.5 meter from the facade, and the spacing between the sprinklers should not exceed 2 meters, you need to design your facade to have a solid 1 meter height parapets. And as you can remember, we have some common path of travel and travel distance limitations. And these limitations are changing with the existing of automatic fire suppression system, sprinkler system. That's why even if the sprinkler system is not mandatory within your building, the architects can prefer to have sprinkler system to use smoothest common path of travel and travel distance limitations. It is up to architect's decision. As architects, you will define the existence, the provision of sprinkler system according to the travel distance measurements of your building. As you can see, if you have a sprinkler system, the limitations becoming more smooth, more flexible, and it is changing your design restraints. Even if you don't need to have a sprinkler system as per Turkish fire code, according to your design requirements, according to the architectural design of your building, you can prefer to ask to provide sprinkler system from mechanical designer. I'm passing these ones. Sorry. And while you are designing your building, if you have a sprinkler system within the building, the heart of the sprinkler system is the fire pump room. Without having a fire pump room, the system won't work. That's why we need to locate these fire pump rooms and at places where is accessible in case of any fire or in case of any other emergency situation. That's why we are trying to provide direct access from staircases, and uh, mm, you need to have about 150 cubic meter up to 300 cubic meter of water tanks to feed the system. It is changing from 60-minute to 90-minute capacity according to the occupancy classification of the designing of the building design. But you will have a water tanks, and you will have some huge water tanks within your building. Since statically solving these heavy equipment is very challenging, they are always preferring to locate them on the lowest basement floor, so that all the load to be supported by the ground, and you don't need to find a challenging solution for the from the statics point of view. That's why generally the fire pump room is located within the lower basement floor. But in the basement floor, this fire pump room should be 2-hour fire rated, so that even if you have a fire within the car park or the neighbor occupancy is just next to the fire pump room, your fire pumps can continue to work in case of any fire as well. And during the fire, either technical team of the building or the fire brigades may require to reach fire pump room to see whether everything is going right, or to interfere any kind of fail to stop the fire pumps, to start the fire pumps. That's why even if even if the whole level is affected by smoke and heat in case of any fire, you should have a easy and safe access to the fire pump room. That's why direct access to the staircase is very important and required by the codes and standards, international codes and standards. That's why as architects, when you are designing the building, you need to find the proper location for the fire pump room. And the sprinkler design has some pressure limitations as well. Uh, we have some minimum pressure requirements at the top level, and we have some maximum pressure limitations on the bottom floor. That's why every sprinkler system is vertically zoned, each of them to not exceed 45 meters. It means for every 45-meter part of your building, vertical 45-meter part of your building, there will be separate vertical pressure sprinkler zoning. And up to 3 zone, it means up to 135 meters, you can solve the sprinkler design from the main fire pump, which is located on the basement level. But if your building height exceeds 130 meters, then you need to provide an intermediate level fire pump room to feed the upper floors, and it will cause a challenge for your architectural design. You need to find a place at this higher level to locate the fire pumps and also water tanks. But these water tanks capacities are relatively small according to the main water tanks. These are only 50 cubic meter. That's why that will not cause a lot of problem regarding static design. But you should warn and you should inform the static designer that there will be fire pumps. These are rotational equipment. These will cause vibration. And also you will have a water tank at this level, so that the static designer take these details into account and design the floor. When you look at the very high-rise buildings, you will see that at some intermediate level of the building, there is no glazing, but louvers instead. That's because of these intermediate level technical rooms. It is located around 130 meters. And when you look at the building, you can understand where is the international intermediate level technical room. It is easy to understand when you look from the outside of the building. As architects, you need to know that you will have this kind of a technical room if you are designing a very high-rise building. Sprinkler system design also requires some design points that is crossing with the architectural design. For example, sprinkler risers and landing valves and control. We are calling that control valve set. In every floor, we have a valve, we have another equipment, and from passing these equipment, our water is reaching to the floor and protecting the whole floor. But these equipment and also the landing valve should be located within the fire escape stair. And the main reason fire escape stair is considered a safe place, and in case of any fire, you can reach to the fire escape stair without having any risk. That's why all of these fire safety related equipment are required to be located within the stair landing. Also, when the fire brigade comes into the building, they will use these landing valves to take water and interfere the fire. Therefore, in order to have a safe preparation, they are preparing themselves within the landing of the stair, and the landing valve is found within the staircase, so that they prepare themselves, they prepare their hoses, and they attach their hoses to the landing valve and go into the floor to interfere the fire. But when you are locating these equipment, these pipes and risers within the fire escape stairs, you should pay attention that these should not be located within the clear width of the staircase. This is the stair circle and stair semicircle, and all of these equipment should be located outer of this required width. This is very important. Otherwise, you probably will have some troubles with the local fire brigade during the acceptance phase. That's why you need to ask MAP contractor, MAP designer, how many pipes will be located within the staircase and how many reservation are they requiring, so that you can determine the required width of your landing. It probably will be larger than required, but these areas will be used for MAP installation. And also, if your building has fire service access elevator, we recommend to provide these riser and landing valve in the stair which is neighboring the service access elevator, because as you can remember from the last lessons that we held together, the fire brigade is coming up to one floor below of the fire incident, and they are preparing here, and they use the landing valve, and they go into the fire fire incident floor. That's why it is very important that they have a landing valve within the stair. Why we are locating the landing valve within the stair instead of this fire protection lobby? Because there can be a water leakage from these landing valves, and if the water leaked within the lobby, it can reach to the elevator well, and it can cause a fail of the elevator. That's why instead of placing these landing valves into the uh, fire protection lobby, we are preferring to place it within the fire escape stair. So in case of any leakage, the water will not come into the lobby. Instead, it is going down from the stairwell. And also, while checking the sprinkler design, it is very popular nowadays to use baffle ceilings or open grid ceilings, but nobody knows their effect to the sprinkler system. When architectural these laminated baffle or grid ceilings is designed and provided, the architect doesn't want to see any kind of installation beneath the ceiling. But as per NFPA, if you don't if you don't want to locate sprinkler beneath these ceilings, you have some provisions. It means the opening rate of this ceiling should be not less than 70%, and the spacing between the laminations should be not less than the depth of the lamination, and also this hash, which is the vertical distance between the sprinkler and the baffle ceiling, should be not less than 45 or 60 centimeters, so that you can omit the sprinkler beneath the ceiling. If you don't know, if you are not aware of these rules, and if you design your ceiling which is not fulfilling these requirements, at the end of the day, the fire consultant of your project will require you an additional layer, will require from you to provide an additional level of sprinkler system beneath the ceiling, and it will change your design, it will change the look of your ceiling. That's why it is also important. And these are our sprinkler systems. The colors cannot match with your interior design, but we are not allowed to paint these sprinkler systems on the side. It should be remembered during site checks, and architects for site consultant, architects who will work as a site consultant. It should not be painted on the side. Instead, while you are procuring at the procurement phase, you can ask the manufacturer, you can give them the RAL code of your ceiling, and they can produce you, they can manufacture you sprinkler heads with the same color of your ceiling. If you don't want to see these details, the deflector and the activation bulb, you can use these recessed type, concealed type sprinkler systems. And concealed type sprinkler system has some plates. These plates are also not allowed to be painted, but you can procure it, you can buy it with a RAL code which is matching your ceiling design. But all of these coordination, the code selection, the color selection, and the procurement should be coordinated by architect, and all of the required information, for example, the color code of your ceiling, the selection, the preferred type of the sprinkler heads, either semi-recessed or concealed, should be defined and determined by architect. That's why you need to know, you need to inform the mechanical designer accordingly. And as you know, we have fire hoses within the floors, and these hoses are not liked by architects. Architects don't want to see these fire hose cabinets, and they are always requiring to cover it with uh, decorative floor finishings. But if you do that, you need to, we are allowed to cover these hoses by floor finishings, but we need to emphasize that we have a fire hose cabinet at the back of this wall covering. And as per an FBA, we have some pictograms, we have some definitions for proper signage. We need to follow it. We need to provide signages with the required dimensions and with required contrast colors, so that in case of any fire, the occupants of the floor can understand where is the fire extinguisher and where is the fire hose cabinet, so that they can interfere the fire at the beginning phase, and they can prevent the fire to be developed. And these embedded flash type fire hose cabinets are not allowed to be located within the fire rated wall, because when you embed this kind of material into the fire rated wall, the main thickness of the wall will be gone, and the thickness of the wall is creating this fire rating. That's why if you would like to locate your fire hose cabinets onto fire rated wall, and you would like to you would like to use embedded or flash type hose cabinets, then you need to design your wall construction. You need to design your wall with having a convenient niche on it. And owing to this niche, without damaging the wall, you can locate your fire hose cabinet, and it can look as an embedded flash type cabinet from architectural point of view. And as we told, we have for some situations, for high-rise building or for hotels and dormitories, we will have some corridor smoke exhaust system design, and this corridor smoke exhaust system should have smoke shaft, and also in order to achieve smoke extraction, we need to have a fresh air shaft as well. We need to provide a fresh air, and then we need to extract it from the floor. It means we will have at least two additional shafts and the dimensions of these vertical shafts are depending on the capacities of the smoke extraction system. And the locations are really important. The the locations are generally determined by architects, even if the mechanical designer insists on some locations. If it's not accepted by architectural team, it is not applied on the site. That's why, as architects, you are responsible to find a proper location for the shafts. Just to information, the exhaust shafts is selected, is determined as far as possible from the stair entrances. And makeup, it means fresh air shafts, are located to the nearest points of the staircase so that when you provide fresh air just next to the fire escape stair, and when you extract the smoke from the farther location, you will move the smoke from entrance of this fire escape stair to the center of this corridor. It means you will keep smoke-free the entrances of your fire escape stair. This is the main design principle that architects should be known about. And also, if you have a pressurization system, uh, the pressurization system is preventing smoke to enter the fire escape stair by giving fresh air into the stair wells. That's why the location of the pressurization fan is very important. You either need to locate it to the top of the stairwell, it means outside of the building, or you can locate it the fans within the building. But when you locate the fans within the building, the room where the fans are located will be considered as a part of fire escape stair. It means it should be 2 hour fire rated and separated from other areas. And if the fan is located outside of the building, but you need to have a duct between the fan and the stairwell. This duct should be 2 hour fire rated insulated so that you can consider that your shaft is extended up to the fire system pressurization system fan, and it will be safe in case of any fire. Our main purpose is to keep the integrity of the fire compartmentation of the fire escape state. The main purpose of these two separate detailed design is to ensure that integrity of our fire escape stair fire zoning will not be interrupted by any other equipment or occupancy within the building. And if the stairwell height exceeds 25 meter, we are not allowed to single injection, which means giving air from the top of the stairwell. Then we will need a pressurization shaft for multi-injection. It is achieving a good pressure a good pressure equivalence within the stairwell. Otherwise, if you just give air from the top, the higher floors will have relatively high pressures, while the lower floors will have less pressures, and it will cause a stack effect, and smoke can interfere. Smoke can go through the stairwell, and it will cause a life safety problem. That's why if the construction height, if the stairwell height exceeds 51.5 meter, we need to have a pressurization shaft, and this shaft should neighbor the fire escape stair like that, because pressurization shaft is a part of fire escape stair. It should be considered as an extension of the fire escape stair. That's why it should be just next to the fire escape stair, and the wall between the fire stair and the pressurization shaft, this one, should not be required to have fire rating, but all of these three walls should be fire rated. That's why if you are designing a high-rise building and if your building needs a pressurization shaft, it should be designed at the beginning of the project. Otherwise, finding a place for that 1 square meter shaft will be a huge problem during your core design. You need to take place from other shafts or technical rooms, or you need to enlarge the core, which will not make the investor happy. And also, as I stated, the required area for the pressurization shaft is about 1 and 1.1 square meter. And the aspect ratio is also important. It means the ratio between the length and width of the stair shaft. It should not exceed 1/4 because otherwise, even if you provide 1 square meter, the shaft will not work as required. It will cause a lot of pressure drop and the system won't work. That's why while designing a shaft, it should not be very narrow. It should not be very wide. The aspect ratio should be kept between 1/3 and 1/4 so that it can work as required. And when you are designing a car park, you will need exhaust system as well. Only for open car parks, as you can see from the figure, smoke extraction system is not required. But all of the enclosed car parks should be equipped with smoke extraction system, which are also requiring additional smoke exhaust and makeup air shafts. What is the open car park? It is naturally ventilated. That's why smoke extraction system is not required. But in order to classify one car park as open, at least 5% of the floor area should be provided on the facades. It means the opening on the facades should be not less than 5% of the largest floor area, and at least half of them should be located face to face so that we will have a ventilation, natural ventilation on the floors. And for the enclosed car park, as we stated, we have to provide a smoke extraction system. There are different type of smoke extraction systems. There are ducted types of smoke extraction system. There are jet fan systems, and you can see here ducted type of smoke extraction system, but it is taking a lot of space from the floor height. And as you know, due to the investment issues, the height of car park levels are tried to be kept in the minimum. That's why nowadays you cannot see a lot of these ducted systems. Instead, they are using these jet fan systems. Jet fan systems are fans, standalone fans, and they are not cause a loss of floor height. That's why they are preferred, and you can ask the mechanical designer to take the floor height limitations into account and to provide jet fan system. But what is the negative side of the jet fan system? It is requiring exhaust shafts and it is requiring makeup air, fresh air inlets. That's why you need to discuss with the jet fan designer to understand how many shafts is required. And these shafts should be located in such a manner that we can route the smoke from the makeup point to the exhaust point without having a bypass. If you locate these shafts just next to each other, instead of extraction smoke from this part of the car park level, you just bypass the fresh air and the system won't work. That's why the shaft locations and the number of the shafts should be coordinated with the jet fan designer, and this coordination is also done by the architectural team. As you can see, this is the proper shaft location. The fresh air comes from this side, and jet fans take the smoke and put them on the other side, and by this extraction shaft, it is exhausted. This part was about electrical system. We finalized and we summarized the mechanical system requirement, and now we have some electrical issues. This is the main fire detection and alarm system example. And you will have a security CCTV center, and all of our fire equipment, fire detection alarm equipment is generally located within the CCTV rooms because there are 724 staff within these rooms to follow the systems. And also they are responsible to follow the fire detection and alarm system. And we are calling it Fire Command Center. It is similar to fire pump room. It should be accessible at any point, at any time, even if the building is having a fire incident. We should reach to the fire command center easily and by a safe way. And this room should be 2-hour fire rated so that it will not be affected from fire incident. And it should have a direct access from a staircase so that fire brigade or technical staff of the building can reach easily and by safely, even in case of fire. And we will have a manual call points, which is not architecturally looking good equipment, but it's mandatory. It should be mounted between 1.1 and 1.3 meters so that everyone can use it. And you will see it on your main corridors. There is no any other alternative to do this manual call points. And as you can see, at the entrance to the exit access routes or at the entrance, just next to the exit access doors, we will have some fire manual file call points. Um, According to the Turkish fire code, manual call points is required for this kind of building. But as architects, you probably will be responsible for high-rise building. These systems are mandatory for the high-rise building. And the main schematical show of the fire alarm and detection system is that we will have some automatic detectors. We will have some alarm indication device such as flow switches to understand if there will be a flow, or we will have some kitchen hood system activation modules. Also, same for the clean agent. It means we are doing a supervision for all of the fire suppression system, fire detection system, and we will be alerted in case of any activation or failure. And also, if you have this kind of grated ceiling, as we talk for the sprinkler system, if you would like to locate your fire detectors within the ceiling void and you don't want to locate it beneath the ceiling, then the ceiling opening ratio should be not less than 70% as per an FPA, but it is 40% as per European by fire node. If you'd like to omit fire detectors below ceilings, you need to take these opening ratios into account. And also, another alternative to these physical detectors, it is generally used in this kind of wooden buildings. Instead of having a spot type detectors, you can use this air sampling type, which is much more smaller than the spot type detector. Or you can use these beam detectors, or call it OSIT detectors. You only have transmitters and receivers on the walls, and you will not see any kind of equipment on the wall, on the ceiling. If you will be responsible for renovation or refurbishment of this kind of historical buildings, or you have a very challenging architectural design of ceiling, Instead of having a spotlight detectors, you can offer electrical designer to use air sampling or beam detector. This is the spacing rule for the detectors. We have a limitation, the spacing between the detectors, and it should be taken into account because the reflected ceiling plans are prepared by architects on the site, and architects are always changing the location of these fire detection equipment according to the other installations found on the ceiling. But these spacing rules should be taken into account while preparing reflective ceiling plans. Otherwise, when you send the final design to the consultant, you will get comments about it, and they will ask you to make code compliant. An automatic detection system is mandatory, is becoming mandatory according to this table. It is Appendix 7 of the Turkish Fire Code. You can see it from Turkish Fire Code as well. And we have some audible and visual alarm system. We need to provide this system, and especially not speakers, but especially strobes are not preferred by architects, but we need to have it according to Turkish Fire Code and also according to the international standard. For these visual alarms, we are checking the light intensity, so that even if you cannot hear the voice alarm, you can be disabled, or you can wear headphones, or you can wear some noise canceling type earphones, so that you can see the visual alarm. And the spacing of these strobes are defined and determined according to this light intensity. And you can see some tables to define the spacing of the strobes. It means when we are locating these strobes, flashers, these are referred from standards and calculations, as you can see. And this is one of the example of the strobe. It can be located either on the ceiling or on the wall, but you need to inform electrical designer your preference, locate your preferred location of the strobes, because the type which is used on the wall is not the same equipment that they are using on the ceiling. That's why at the beginning of the design phase, you need to inform electrical designers that architecturally strobes are required to be on the ceiling, or they are required to be located on the walls. And we will have an emergency announcement system. These are the speakers, and it is called public announce and voice alarm system. And we have some minimum sound level requirements. That's why we should have at least one speaker at every room. It means locating speakers only at the common corridors or common areas will not solve the issue. We need to have speakers within every room, and the ceiling design and the ceiling coordination should be done accordingly. And in hotels and dormitories having an occupant load more than 200 beds, or public buildings having an occupant load more than 1,000 people, or in high-rise building having a construction height more than 51.5 meters, we need to provide this emergency public announcement voice alarm system. And this is the room now I am making my presentation to you. We made it as an example. We have a fire detection spot type fire detector. We have a speaker, we have a visual alarm system, and we have a sprinkler system. And they are all coordinated on the same line, so that this is done by architectural team, and they are defining the locations. And as you can see, since we don't have 1 meter parapet in the facade of our building, we have a closely located facade protection sprinkler as well. Even if we don't need it by distance, it is provided because of Turkish fire code requirements. And also we have emergency lighting. This is a good example to understand main principle of the emergency lighting. The exit rules and the fire and life safety equipments and the main technical rooms should be protected, should be equipped with emergency lighting system so that in case of any kind of energy loss, these areas can be found by occupants and egress can be done safely. In high-rise buildings and uh, below ground level with occupant loads more than 50 people, or if the building have the occupant load more than 200 people, dormitories, hospitals, and other high-risk areas should be equipped with emergency lighting fixtures as well. And exit signage is also important. According to the Turkish fire code, it should be these types. The background is green and the pictograms are on white. This is not by chance. When you see the spectrum of this visibility according to the colors within the smoke, the most easily the green color is the most easily seen spectrum. It has the larger spectrum. That's why the exit signage are determined to have green background and white pictogram level. That's why we cannot change it. It is written in the Turkish fire code, even if it is not parallel to your interior architectural design. These examples should be used, and we prefer to use without letters only this arrow and running man and door, because if you have a çıkış right on your plate, you need to provide the English translation as well for your international occupants. And the locations should be like that, so that the occupants can understand the exact location of the exit access door. This is an example from Istanbul Airport where we were the consultant, fire and life safety consultant. As you can see, these are the wayfinding plates, and we provided this special design so that it can be understood. You can understand that this is an emergency exit signage, and if you follow these green ones, you can reach to the exit access. But the other ones are showing the restrooms, the restaurants, or the gates. And also the um, emergency equipment should be feed by both main electricity and also the diesel generator. And that's why it is important to find a place for automatic transfer switch when you are designing a room for fire pumps, for pressurization fans, or for smoke extraction plants. This is a panel, and we need to provide it within the room so that it can feed the emergency equipment without having an interruption. And also, within the electrical rooms, you will have some electrical vertical opening, cable vertical shaft. And when the cable pulling is done at the end of the day, before commissioning of the building, all of these cable shafts should be filled by 2-hour fire-rated fire stopping material, so that the compartmentation integrity can be achieved. This was all that I would like to summarize you for architects regarding MAP point of view. As we stated before, architects will be responsible for the coordination of the system and the coordination of the site. That's why it would be better for you to understand the main principles of fire and life safety requirements. And it will make you more successful architect if you know about multidisciplinary requirements of the building, so that at the end of the day, with minimum revisions, you can finalize your project and you can commission it. Thank you for your time, and thank you for listening. Thank you, Hocam.